Okay, good afternoon. This is a video to go over the questions from your last midterm exam. And so starting with question one, this is dealing, all the answers are dealing either with, what's the limiting reagent, how much is left over, what's produced, and you're given grams of both of these, so we have to figure out which is limiting. And so 5 grams of each, and so we have to divide by the molar masses, or atomic mass for iron. And so that's 55.85 grams per mole from the periodic table, and water is 18. Okay. And so, let's see. 5 divided by 55.85 is 0.0895 moles for iron, and water is 5 divided by 18 is 0.278 moles. I guess too many sig figs, but whatever. Okay, so now to figure out which is limiting, how much is left over or whatever, I like to, I mean, you could do it to figure out which is limiting. You could divide the water by 4, because there's a 4 in front, and then the iron by 3, okay? And so if you do 0.278 divided by 4 versus 0.0895 divided by 3, and you compare those, okay, so that divided by 4, you get 0.069, okay, and then the other one divided by 3, you get 0.030. Okay, so that's the smaller number, and so that means that iron is the limiting reagent. Okay, so I guess, it's asking which one is false in this question, so I guess you know that that's false, right? So without doing any of the others, you know that that's the false answer. If you wanted to get into, how much water is left over, or whatever, I would do it where you convert one into the other. And so, for instance, if you have 0.0895 moles of iron, then if you multiply it by 4/3 or divide by 3 multiplied by 4, then you get the moles of water that are needed. Okay, so let's do that. So 0.0895 times 4 divided by 3 gives you 0.119 moles of water are needed, but you have 0.278. So that tells you you've got more than needed. I guess more than needed. So therefore it's an excess. Okay, and then iron is limiting. But what's nice about this is then you could just say, okay, if you so if you need 0.119, but you have 0.278, if you just subtract them, you get 0.159 moles of water left over. And then if you multiply by 18, the molar mass of water, then you get 2.85 grams left. Okay, and so that, that one's true. And then you could calculate the iron oxide that is produced, I guess with all my scribbles here. And then let me erase all this. There we go. Okay, so if you know the limiting reagent is iron, and you know you have 0.0895 moles of iron, then if you divide by 3, that gives you the moles of Fe3O4. Okay, and so that's so related to this one. You have 0.0298 moles produced, and then if you multiply that by the molar mass, 55.85 times 3, and then 16 times 4 times 231.55, you get 6.91 grams. Okay, so that is also true. And then mass is conserved, so that's always the case. Okay, so that is the only one that is incorrect. Okay. All right, so for that question, yeah, there was a short way to do it. You could say B is incorrect right away because you can know iron is limiting, or you could do the calculations to figure out all the others are correct. Okay. Question 2, you have a variety of these: acetic acid, formic, hydrofluoric, and then ammonia and methylamine. And so unless an acid is one of those 6, okay, so these are strong acids, also known as strong electrolytes. Okay, none of these acids are on this list, are they? So these are weak acids or electrolytes. And the only strong bases are things like sodium, potassium, whatever, so the group 1s, or the group 2 hydroxides, right? So NaOH or barium hydroxide, any of those, these are strong. But any of these ones, that's not on the list, so those are also weak. Okay, so so all of those are either weak acids or bases, and so they're weak electrolytes. Okay, a non-electrolyte is something just organic that is not an acid, okay, or a base. All right, the next one is in words. Calcium phosphate reacts with sulfuric acid. So let's write this here. So calcium and then phosphate. Remember, phosphate is PO4 3 minus. So what does that mean? So that means then if that's 3 minus, and you've got calcium that's 2, so you're going to need a 3 there and a 2 there. Okay, to balance the charges. Then it reacts with sulfuric acid to form calcium sulfate plus phosphoric acid. Okay, then we balance it, so we're going to need 3 of those. 2 of those, and 3 of those, I think, right? So is that balanced? 6 oxygens, 2 phosphates. Yeah, okay. And so it's asking, what's the stoichiometric coefficient for sulfuric acid? That would be 3. Okay. Determine the number of water molecules necessary to balance. So this is the reduction half reaction. So this is telling you electrons should be on the reactant side if it's saying reduction, right? So it's kind of giving you a little hint, but MnO4 minus goes to MnO2. Okay, the manganese are good. We have to balance the oxygens by water. Okay, and this is in basic solution. I scribbled over it, but it's in basic solution. So now that's the oxygens are good, but now hydrogens. So we're going to need 4 H pluses over here. Okay, and now everything is mass balance we have to do for charge. And so this is neutral over here. This has a charge of +3, right, because +4 minus 1. And so you're going to have to add 3 electrons over there. Okay. And so now in acidic solution, that would be it. But in basic solution, you have to add 4 OH minuses to both sides. Okay, and so this will make 4 waters. So just kind of to do a tally here. Okay, and then you can cancel 2 waters from either side. Okay, and so we end up with 2 waters. Okay, this is dinitrogen monoxide, or laughing gas, or nitrous oxide. Decomposes to form nitrogen gas and oxygen gas. Remember, these are diatomic. So you have to have 2, O2, N2. Now, so how many grams of oxygen are formed when 5 grams of N2O decomposes? And we want to know grams of that, okay? So here we divide by its molar mass. And so that would be nitrogen is 14 times 2. And we've got another 16. So that's 44 grams per mole. So 5 divided by 44 is 0.114 moles. Okay, and I guess I forgot to do it, but I guess it's still not too late to do it, is balance, right? And so oxygen, you have 2 there. So you need a 2 and a 2, okay? And so now to get moles of O2, I have to divide by 2. Okay, so divided by 2 is 0.057 moles of oxygen times 32 grams per mole. So each oxygen is 16, and you have 2 of them. So that times 32 equals 1.82 grams. Okay, which is the answer. How many anions are in that many? Okay, so anion means the negative charged ion. Okay, so MgBr2, you can think about it like that. You know, like remember the question I had on the practice midterm in your last homework assignment. So for every one of these, you're getting 2 ions. Okay, and so if you have 0.5 grams of this, and this time I'm going to have to use the periodic table. So to get the moles, so magnesium is 24.31, and bromine is 79.904 times 2. So that's 184.118 grams per mole. Okay, so that's 0.0027 moles of magnesium bromide. And so to get moles of bromide, you have to multiply by 2, right? Because it's a 1-to-2 ratio. So that times 2 is 0.0054 moles of bromide. And then this is asking how many, so that tells you have to multiply by Avogadro's number. Okay, so you're going to get like a huge number, O2e to the 23rd, and that gives you your 3.27 times 10 to the 21. Okay. How many grams of silver nitrate are needed to make 250 mils? That's that many. Okay, so if you have 0.135 moles for every 1,000 mils. If you want 250 mils, then how many moles do you need? So I would set up as a little ratio. And so that tells you that you have 0.135 times 250 divided by 1,000, 0.0338 moles of silver nitrate. And then to get grams, we just multiply by the molar mass. And so silver is 107.87. Nitrogen is 14.01. And then we've got 16 times 3. So that's 169.88. And that gives you 5.74 grams, okay, which is essentially that. Okay. How many grams of the excess reagent are left over when you have 6 grams of this guy reacting with 10 grams of chlorine? Okay, so sulfur is 32.06. 32.06 and 12, whoops, times 2 plus 12.01. So that's divided by 76.13 grams per mole. And then chlorine is 35.45 times 2 is 70.9 grams per mole. Okay, so 6 divided by 76.13, 0.079 moles. And then this one is 10 divided by 70.9, 0.14 moles. Okay, so in this case, it's asking how many grams of the excess reagent are left over. So I would, it works out easier if you do it, find out how many moles you need and how many you have to do it that way. And so I always like multiplying instead of dividing. So I'll take this number of moles of CS2, or carbon disulfide, okay? And if I multiply it by 3, I can find out how many moles of chlorine I need. So 0.079 times 3, okay? So I need 0.237 moles of chlorine, okay? But I only have 0.14, okay? And so that tells you that chlorine is the limiting reagent. Okay. And CS2 will actually be in excess. Okay. And so now let's flip it the other way around. Okay. Now that we know that carbon disulfide is the excess. So if you have 0.14 moles of chlorine, then let's divide that by 3. So 0.14 divided by 3 is 0.047 moles needed of the CS2, okay? But you have 0.079 moles, okay, so in excess. And then how easy it is, you just subtract the two of these. So therefore, 0.079 minus the 0.047, you have 0.032 moles of CS2 left. Okay, and then to get the grams, you just multiply by 76.13 grams per mole. So that's your 2.46 grams left. okay, which is that one. Close enough. Okay. All right, next one. How many moles of boron trichloride are needed to produce 25 grams of HCl? Okay, in this case, so we have 25.0 grams divided by chlorine, just to make sure, yeah, 35.45. So that's 36.45 HCl. Okay. So 25 divided by 36.45 is 0.69 moles of HCl. Okay, and now it's a 1 to 3, or a 3 to 1 ratio, right? So you have to divide by 3. So divide by 3, that means 0.229 moles. Okay, and in this case, it's actually easy, right? You don't have to do that final step of converting it to grams. Okay. How many oxygen atoms are there in so many grams of CO2? This is like the other one. So we had one like it earlier in the exam with the anions, and there's one on the practice exam. So for CO2, there are 2 oxygen atoms per CO2 molecule. Okay, so what we do is first 52.06 grams, and then divided by 44 grams per mole is the molar mass. 2 times 16 plus another 12. So 52.06 divided by 44. And so we have 1.18 moles of CO2. And so therefore we have, multiply that by 2, we have 2.37 moles of oxygen atoms, right? Because there's 2 for every molecule of CO2. Once we have moles, then we multiply by Avogadro's number to give you the number of things. So how many are there? And that gives you your 1.42 times 10 to the 24th. Okay. Okay, finally an easy one here. Or a non-calculation one at least. So the spectator ions in this one, I suggest you write out the total ionic equation. Whoops. Okay, and I'm forgetting the AQ little subscripts there. Okay, this stays together because it's a solid. Okay, and then you're just seeing what can be canceled from either side. Okay, and you can cancel H plus and NO3 minus, so those are the spectators. Molarity, so just a definition for you. Capital M is always moles of solute over liters of solution. Okay, not solvent. Another just definition. So if you think about it like this, oxidation is loss of electrons, reduction is gain. Okay. Balance reaction between nitric acid and aqueous strontium hydroxide. So you have to remember that it's that. Okay, and then you're going to swap partners with this. So you're going to get water. It's an acid-base reaction, so you're going to get water and a salt as your products. And then you're going to get strontium nitrate. Okay, and so you have that. And then you balance. Okay, so let's see, strontiums are good. Nitrates, though, we need a 2 there. and then a 2 here. Okay, so I think that's it. Yeah. 2 waters and that. Okay, so that one matches that. Chemical formula for sulfurous acid. So remember, if you have an 8 suffix, then the acid is sulfuric. So 8 goes to ic. Okay, so that would be H2SO4. In this case, we have SO3, so that's sulfite. Okay, so the ITE suffix goes with sulfurous acid. Okay, so just remember 8 goes with ic, ite goes with us. Okay, so that's an easy way to kind of remember going from ions to acids. Sulfuric acid and sodium hydroxide. So sulfuric and sodium hydroxide. So if you do it just as the molecular equation first, and then you're going to have Na2SO4, okay, which means you need 2 there. And 1, 2, 3, 4. So you need 2 there also, right? So that's 4, 5, 6 oxygens. Yeah, okay. So you have that as your molecular. Now you break it down. And let me put these guys. Okay, so now you break it down. So you've got 2H plus SO4, 2 minus, plus 2 sodiums, plus 2 hydroxides, goes to 2 waters, so that stays together, plus 2 sodiums, plus sulfate. Okay, and then you cancel all the spectators. Okay, and you end up with that. Okay, so basically it's just proton reacts with hydroxide to give you water. Okay, so and you can divide everything through by 2. Okay. Okay, activity series. So we had one of these in the practice exam also. So higher up means it oxidizes easier. So that means that sodium, between sodium and chromium, sodium would prefer to do this. Okay, and chromium prefers to do this. Okay, I guess you need 3 electrons with them. Okay, so this is the preferred way that they want to react, okay, based on how they appear. And so this is saying that sodium is going to react with chromium 3+. Okay. Empirical formula for this organic compound. So you assume 100 grams of sample. So we've got 81 grams of fluorine and 19 grams of carbon. Okay, then you divide by their atomic masses. Okay, so 81 divided by 19 is 4.26 moles, and then we've got 19 divided by 12 is 1.58 moles, okay? And then you divide both by the smallest one, okay, to get the ratio. And so then 4.26 divided by that is 2. So we have essentially then, so C, F, 2.7, something like that, okay? because this worked out to 2.69, the 4.26 divided by 1.58. Okay, so we have that, but we have to get it in terms of integer numbers. And so you have to think about, what can I multiply everything through so that you get, integers or close to integers. And so if you multiply everything through by 3, then you get C3, 8, and this works out to like 8.08. Okay, so that's close enough to 8. Okay, so that's where C3F8 comes into play. Okay, so for this question, a single chlorine molecule, remember it's diatomic, right? So if we have a single molecule, if we divide by Avogadro's number, this is essentially like molecules per mole, okay? Then you end up with so many moles of Cl2. Okay, so if we do 1 divided by Avogadro's, we get 1.66 times 10 to the minus 24. Okay, and then to get moles, we would have to multiply by the molar mass. So it's 35.45 times 2. So that's 70.9 grams per mole. Okay, so 70.9 times the 1.66 e to the 24 minus gives you your 1.17 times 10 to the minus 22 grams. Okay, the molar concentration of sulfate ions in that solution. Okay, so this one, so you have Na2 SO4, and it's asking for what is the sulfate concentration for that. Well, this is saying that for this salt, if you have one of these, then you will break this apart into like 2 of those and 1 of those, right? So for every mole that you have that, you're going to have the same number of moles of this. And so if you have 0.150 moles per liter of the salt, you're going to have that same concentration, or 0.150 of sulfate ions. To look at it a different way, if you were to ask how many sodium ions, what's the concentration of that? It would be 0.15 times 2, so that would be 0.3 moles per liter is the concentration of sodium ions, because you're getting 2 of them for every one of these, right? Because there's a 2 here. The molar mass of calcium permanganate, and so I guess here it just you'd have to remember, I guess, the permanganate is MnO4 minus, and so that's calcium. And so the formula is really this. Okay, and then you just go to the periodic table. So manganese is 54.938. Calcium is 40.078. Okay. So 40.078. And then you've got 2 manganese and 8 oxygens. Let's see, add up all those and you get 277.95 grams per mole. Or I guess the closest is 278. Oxidation number of the sulfur atom, so H2SO4. Okay, so oxygen you can assume are -2 each. Okay, so that means you have a -8 here. And so this whole other side has to equal +8. You know, hydrogens are +1 each. Okay, so that means that each of the sulfurs have to be or I guess there is one, only one sulfur, is +6, right? So that means you have +6 +2 from the 2 hydrogens equals +8, and that will match the -8 that the oxygens have. And then just a balancing equation here. So I would do phosphorus first. So you've got a 4 there. Then maybe, well, I guess hydrogen. So if you do that, so you've got 12 there. So let's do a 6 there. And now let's do oxygen last. So you have 16 over here. So you need an 8 over here. Okay, so you're adding all these coefficients. So it's 4 + 8, and then another 7 on top of that. 8, 9, 10, 11, 12, 13, and 6 is 19. When aqueous solutions of blank are mixed, the precipitate forms. Okay, so in this case, I guess it had all these as possibilities. That's a lot of choices. So this one, you're going to form NaBr and Ki. Okay, so if we just kind of go through, see what the products are first. This one, you're going to get a lithium iodide and cesium carbonate. So that's going to be cesium-2 carbonate. And then this is going to be KCl and chromium. That's chromium-3. So that means you're going to have a 2 and then SO4 × 3. Okay. This one is going to be a nickel 2 nitrate. So it's that. And silver bromide. And then this one is going to be KNO3 and barium hydroxide. Okay, so again, they're just swapping partners. So the potassium steals the nitrate, barium steals that, nickel goes with that, okay, etc. And so for this, you're just going to apply the solubility rules. And so all group 1s are soluble. So that means that's soluble and that's soluble. That's soluble, that's a group 1, that's group 1, and that's group 1. Okay. And then group 2 hydroxides, or most hydroxides are going to be actually some of them are insoluble, but this is a strong base, and so that is not on the list of exceptions, and so it's going to be soluble. There's only a few exceptions for when sulfates are not soluble, and so chromium is not one of them, and then all nitrates are soluble, and so the only one that will form a precipitate is this, so silver bromide. So most, in the solubility rules, most halides are soluble except, and then you'll see a silver there. Okay, which is an oxidation reduction. The easy way is look to see if on one side of the arrow you have an element, the other side you have a compound. And so here you've got compounds going to compounds, same thing here, same thing there. Wait a minute, element, compound, so it has to be redox. And this also is element, or just compounds reacting. This is actually acid base for that. Okay. Which species functions as the oxidizing agent? That means it is reduced. Okay, and so this is going to that. Okay, so it's picking up 2 electrons. So copper 2+ is being reduced. So that means it is the oxidizing agent. This is being oxidized, so that would be the reducing agent. So zinc, in other words, would be the reducing agent. Which one of the following compounds is insoluble? And so again, group 1 salts are soluble, soluble. All nitrates are soluble. So there. Okay, most sulfides are insoluble, except group 1s, really, or ammonium salts. Which one is a triprotic acid? Okay, so that is an example of a monoprotic. Okay, because it just has one proton. This is diprotic because you have 2 protons. This is phosphoric acid, so it's triprotic. You have 3. Which following is a weak acid? So just definition. So that's strong. That's that list that I gave with the 6 strong acids. So all those are strong, and so only one that's not on it is HF. So that's weak. And the last question, which is an empirical formula? So remember, if you can divide everything through by anything other than 1, integer-wise, then it's not an empirical formula. And so this one you can divide through by 2, right? So that would just give you NH2. This one you can divide through by what? By 2, right? So that would be P2O5. This you can divide through by 2, so that would just be CF3. This you can't divide by anything, so that is empirical. Okay, these are empirical formulas for all of these compounds. So these would be the molecular formulas. These are empirical formulas. Okay, and so if you have something that you can't divide everything through by, then it already is an empirical formula. Okay, so I hope that helps. Let me know if you have any other questions. Take care.